Balloon Screencast by Aaron, Sierra, and Janae. How hot air balloons work. Before the balloon is placed on the launcher, it is partially filled with room temperature air. And I know what you're thinking. Duh. When the deflated balloon is inflated on the launcher, molecules in the balloon speed up. This is because warm molecules are introduced, meaning more molecules inside the balloon, and the molecules are moving faster. This means more collisions between the molecules and the inside of the balloon, pushing out the panels and increasing the volume of your balloon. The density of the balloon becomes lower than that of the surrounding air, allowing it to rise and float. This is similar to how large boats work, how even something as massive as the Titanic was able to float on a body of water. Charles's law is demonstrated as the increase in temperature changes the volume, causing a decrease in density. This is because the mass stays the same, and as the temperature inside the balloon changes, as does the volume. Calculations. Charles's law is apparent because the volume of the inflated balloon is greater due to the fact that it is warmer inside of the balloon. This accounts for a greater density of the deflated balloon than that of the inflated balloon. This is why the inflated balloon is able to fly. We will come back to the Prototype 1 launch later. Template changes explained. We designed a template change that allows for the balloon to have a larger area, because greater volume means less density. We assumed that because tissue paper didn't weigh nearly as much as the wire hanger that we were using, that the more tissue paper we used to maximize the volume, the greater volume and the less mass. Things that contributed to this idea were shortening the length of the wire hanger. The less overlap we had in the skeleton of our balloon meant the less mass we had, for that was the most concentrated area. We also constructed shorter, wider, and rounder panels because the shape with the least surface area but the greatest volume is the sphere. We also used thinner tissue paper to decrease the weight of the balloon. Even if it was ever so slight, we assumed that thinner, lighter colored tissue paper would weigh less than that of the thicker, darker variety. We also made a seam length that was shorter to maximize the area of the balloon. We applied more glue to seams and patches to prevent holes and further tears. Because we are putting tissue paper on a cook stove, it is very likely that seams pop open and the unexpected is likely to occur. It really wasn't that hard of a decision to decide to put more glue and time into the seams and our patches. Calculations. As you can tell, the density of this balloon was less than our previous balloon. We can attribute this to our decreased mass. Here's our Prototype 2 launch, which we will come back to. Analysis of Prototype 2. The balloon did not fully expand on the launcher because the changes that were made were less than successful. Our first balloon traveled a longer and higher distance than our second. Excuse me. Although the density was decreased due to a much smaller mass, the balloon still did not fly very well. The widened panels made little difference in volume because they failed to expand fully when on the launcher. This meant that even though we had increased the width of our balloon, we weren't able to maximize that increase and thus had empty weight. This is because we had too much tissue paper and not enough space for the balloon to truly rise. The shorter panels did not work out the way we had hoped, creating a more circular shape. We ended up with a more mushroom shape, which didn't fly as well as we had hoped. Even with the shorter seams, there were many tears that allowed the heated air to escape. We might be able to attribute this to the thinner tissue paper that we used. Because there is give and take no matter what material you use.
Unfortunately, it appears that this will not play when I'm trying to play, but I will describe it as best as I can. So our balloon, as the warm air was introduced into it, expanded quite well. The panels completely poofed out. There's very little rips in our balloon, if there were any at all. It raised and lifted to about the size of the buildings, and then was hit by a gust of wind, which took it down. My second video, which also doesn't appear to be working, tells a similar story, except for our panels did not completely expand. This meant that the tissue stayed folded, and we weren't able to maximize on the volume of the balloon. We instead had dead weight, and it wasn't suitable for flying. It did reach a similar height to our previous balloon, but this was on a second attempt of flying it, and unfortunately did not improve from our previous balloon. Thank you. My apologies for the video not playing.